Good day, viewers. You are welcome to another edition of online mathematics class. Today, we shall be studying bearings and distances. We want to look at the definition of bearings and distances. We want to look at the cardinal points. We'll be taking a short revision on properties of triangle and trigonometry. Then we'll be looking at how we find the bearing between 2 points. And also we'll consider the calculation on bearing and distances. First, what do we mean by bearing? Bearing is the clockwise angular movement between two distant places or points. It can even be position. When we move in a clockwise direction, imagine we have the North Pole and we are moving starting from the North Pole and we are moving in a clockwise direction. So we move towards the east, then the south, then the west before we come back to North Pole. That is clockwise direction. And we consider the angular movement as we are moving. Moving from north to east will make 90 degrees. Moving from east to south, it will make another 90 degrees, making 180 degrees. So all this is what we'll be considering as we study this course. Distance is the length or how far of the space between two places or position. The distance, when we talk of the distance, it is how far or the length measured in kilometers or in meter as the case may be. So we want to look at the cardinal points. We have the north at the top, we have the south at the bottom side, we have the west at the left side, and we have the east at the right side. So this cardinal point, we'll be considering how we make use of it. And do always note that when we want to make our movement, we start from the north and we move clockwise. We move towards the east and we can form the angle while we move. So we move just like this as that arrow is indicating. When we come straight down, when we get to the east, then we'll continue to move and we'll move to the south. And please take note that when we move from the north to the east, it is between 0 degree and 90 degree. When we move from the east to the south, it is between 91 degree and 180 degree, meaning that from the north to the south, it will form an angle on a straight line, which is 180 degree. We can continue to move like that. When we move to the west as well, start from our starting point, it's going to be from the north to that west. According to that clockwise direction, it will form 270 degree. And if it were to be that from the south to the west, it will be angle between 181 degree and 270 degree. So from that west back to the north, it can make an angle of 271 degree and 360 degree. So all these variables, we can find their angle in between. Provided that we are given a certain bearing, we can easily identify that, okay, with this magnitude of an angle, it should fall inside 0 to 90 or 91 to 180 or 181 to 270 or 271 to 360 as the case may be. We'll be looking at various examples as we proceed in this lesson. Just like we have said, this is where we have north and east. That place can be likened to northeast. Any angle formed at that place, we can call it northeast. And where we have south and east, any angle formed at that place, we can also liken it to be southeast. So also we have southwest and we have northwest. So when we take note of all this, please, as we are going on during the course of this lesson, I would want you to make the diagram, take your pen and pencil, and make sure you are taking jottings. So as we proceed, we can easily follow in that order. So we look at an example like having a cardinal point now. Look at this point. Where that point is located, do always have it in mind that there is north, there is south, there is west, and there is east. of that point. And let us say we have another point. That another point is also having the north, the south, the west, and the east. And we can relate to say that one point is at Lagos, another one at Abuja. And when we want to connect that together, considering the one at Lagos, going straight to the one at Abuja, we can say that that angle is showing and it is forming what is the bearing of Abuja from Lagos. Now, having it from Lagos, meaning that we start our drawing clockwise from Lagos and we're trying to locate the bearing of Abuja from Lagos, meaning we have started drawing from that north of Lagos to locate where Abuja is. And as it is, just like we have said, if we are to consider that drawing, it's going to be between 0 degree and 90 degree. So also, if we look at that one at Abuja, we see it that the angle will run from the north clockwise straight down. It will pass through the east and it will even pass through the south, but it will not touch the west line, and it will stop at where the angle is formed coming from Lagos, and it will definitely be between 0 and 270, just like we have said earlier. So let us take a careful look at that, because where that angle meets Abuja, it is between 181 degree and 270 degree, the one we have shown us earlier. So that is that. And let's consider we have a point at Ilorin and we have another one at Uyo. Taking a look at this very carefully, you would see that the angle that it will form at Ilorin, considering that we want to know what is the bearing of Ilorin, of Uyo from Ilorin, please let's take note of that. The bearing of Uyo from Ilorin, then we're going to move from the north clockwise and it's going to be greater than 90 degree, meaning we're going to have the angle, it will be between 91 and 180. It will be between 91 and 180 degree. And from there, we can also consider the one at Uyo. Taking a look at it very carefully, we're coming from the north and we're going straight like that. Let's try to use an indication to show what we are talking about. Sorry, I need to go back to that slide. So what we're saying is that we consider the angle coming from the north clockwise to meet that line that is coming from Uyo. That would form angle that is greater than 90 and it will not be up to 180. So also that of Uyo coming from the north, moving clockwise to go and join that straight line, then we're going to have angle that is greater than 270, but it will not be up to 360. So let's proceed to the next slide. We want to have revision on properties of triangle and trigonometry. We have 4 types of triangle as we know it. We have the equilateral triangle, the isosceles triangle, we have the right angled triangle, and we have the scalene triangle. Considering the equilateral triangle where we have 3 sides are equal, the reason why we are coming through this revision is because as we will be proceeding to study the bearing and distances, we are definitely going to be having shape that will come in form of triangle. And once we are familiar with the properties and all properties of triangle and workings that pertain to it, we can easily apply the knowledge to solve questions on bearing and distances. So as we have this now, equilateral triangle as it is, 3 sides are equal, 3 angles are equal, and there are so many other associated properties to this as far as we can explore it, but the visible ones are the one I will just briefly talk about. And we also have isosceles triangle, 2 sides are equal, 2 base angles are equal as well, and that is an isosceles triangle. We also have right angle triangle. This right angle triangle, the obvious properties that we can speak on this is we have one angle is at angle 90 degree, and we have the longest side. Do not forget the Pythagorean who states the square of the longest side is equal to the sum of the square of the other two sides. So that one is one of the things that we can consider, and we see it to be obvious on right angled triangle as well. We equally have scalene triangle. Scalene triangle has unequal sides. It has unequal sides, it has unequal angle. So let's take careful note of that, and all other properties as we continue to study this course. We're possibly going to be coming across questions that will need us to bring out one or two of them. Now, I want us to have a touch revision on this trigonometry. When we talk of sine rule, we have to consider it on a shape of triangle that is not only in form of scalene, but this is indeed applicable to all triangles. When we have angle A, angle B, and angle C, and we also have side A, side B, and side C. Let's look at this triangle the way it is drawn. Angle A is facing side A, angle B is facing side B, angle C is facing side C. Those sides are represented with small letters. When we have this triangle, definitely this sine rule is going to hold. We're going to have sine A over A is equal to sine B over B is equal to sine C over C. We can equally take its reciprocal as well by saying A over sine A is equal to B over sine B is equal to C over sine C. That one holds as well. And it's not limited to this sine rule. Please take note of this sine rule because we're going to be using it as we study this bearing and distances. Take note of it very well. It's not only this sine rule, we'll also have cosine rule. Cosine rule, and I would want us to study it very carefully and the way it is applicable to this triangle. When we have cosine rule, it can be in any of these three forms. It can be in A squared is equal to B squared plus C squared minus 2BC cos A. Please let's take note of it. We take small letter A as the side, A squared, then we'll come to use cos A, angle at A. Also, B squared is equal to A squared plus C squared minus 2AC cos B. So the one that we are taking to be B squared, small letter B squared now, it is the one that is acting on its angle, cos B. That is how we can study it, because as students we're expected to know all these and having them as instruments to solve related problems on whatsoever coming in form of triangle. So also we have C squared is equal to A squared plus B squared minus 2AB cos C. So these are the trigonometry basic ones that will be applying as we study bearing and distances. Please let's take note of them very carefully. We can see that the side is directly facing the angle and accordingly in that order. Now we proceed and want to start taking questions. We want to take examples on how we do the calculation and how we simplify problems. Let's first consider this. If the bearing of A from B is 65 degrees, what is the bearing of B from A? Meaning that the bearing of A from B is 65 degrees. We're going to have point A, and we have the north, the south, the west, and the east. And we're going to draw an angle 65 coming from the north, moving clockwise, and that is going to form something of this nature. Look at that red arrow. That is 65 degrees. Now we'll consider this place to be our point B, because the question asks us that what is the bearing of A from point B. So we are at point B now. That one at the top is point A. Now we want to know what the bearing will be. As we have gotten to see that we have drawn that 65 degrees, we have drawn it to go and meet point A. We now go back to point A. We start from the north. We draw clockwise and we'll come to meet the straight line coming from point B. And once we meet that, then we measure the angle. We check to know what that angle is. And how do we easily simplify to find out what that angle is? Once we have seen that 65 degree is what we have at point B, we can easily look at its corresponding angle at point A, and the corresponding angle at point A will be the excessive part after we have drawn from the north coming straight to the south to form 180 degree, and the excess part of it to meet that straight line coming from point B is corresponding to 65 degree, meaning that they are equal. So we can easily say that 65 degree plus that 180 degree, and it's going to be 245 degree. And we can conclude to tell them now that the bearing of B from A is 245 degree, as it is because we are drawing it from A to get what is at B, just like we have drawn from B to get what is at A. So this is how we always form, this is how we always come up with how we take the bearing of a point from another point. So it will be definitely from that point that is being mentioned that we will go there to draw the angle clockwise from the north, then to locate the other point. Let's look at another example. If the bearing of Uyo from Ilorin is 118 degree, what is the bearing of Ilorin from Uyo? So meaning that we are going to draw something here that we first get Ilorin, because we want to draw from Ilorin and locate Uyo. And before we can draw anything here, this is 118 degree, that is greater than 90 degree. So it will fall into this second quadrant where we should have 91 to 180, because this is 118. And once we draw that, that will now give us to have Uyo, and we have seen where Uyo is now. So the angle, which is 118, will be what you have just indicated with arrow, and the angle that will be the one that is required of us, that we are asked to find now, that what the bearing of Ilorin from Uyo, we are coming to Uyo. We will now draw the angle to come and meet that straight line coming from Ilorin, which is going to go in this direction, coming from to start from the north, go clockwise and go around like that to come and touch that straight line coming from Ilorin. And once we form that, we're going to have something like this. So 118, that is Ilorin. Then Uyo, that is, look at this 62. That 62 is the later part that would make 360 complete. And how do we come about finding that 62? That 62 is the remaining angle that will make 180 degree complete at Ilorin. Let us look at Ilorin very carefully. Do not forget that we draw 118 degree, but what will make it complete if we continue to draw and let it touch the south pole is 62, and that 62 is corresponding to the remaining part that will make that Uyo form a circle, which is also corresponding to that 62. So this 62 is correspond to that 62. That is why we have this place to be 62. But the question that is being asked from us is that the bearing of Ilorin from Uyo. So we are going to take away this 62 from, we're taking away this 62 from 360 degree. And when we do that, then we can have the question answered, as we are asked to find what the bearing of Ilorin from Uyo is. And once we easily do that, we are going to form 298 degree. So if the bearing of Uyo from Ilorin is 118 degree, then the bearing of Ilorin from Uyo will be 298 degree. Alright, let's proceed and see how we calculate distances and bearing when a question is given. Let's look at this. A ship travels from A, that is from point A to point B on a bearing 45 degree. So the first thing we're going to do here is that we're going to imagine bearing and it's going to form 45 degree. And do not forget that it is from point A to point B. So we're going to have point A, and do not forget that every point they have the north, the south, the west, and the east. So the picture showing us point A, and the northern part, the north is indicated. Then the movement of that ship now, then from B to C on bearing of 140 degree, that is another movement. So when it got to B now, there will still be another movement to C on a bearing of 140 degree. And how do we have that 140 degree? To be between 91 and 180. So we're going to draw another straight line coming to C now. So to do that, we're going to have something like this, 140 degree, and it goes straight down to C. So the ship is then 13.6 kilometer east of A. So the east of A, we're going to locate the east of A, and we direct it straight to where the ship is now, and the distance between that will be 13.6 kilometer, just like what we are showing on the screen. So the A is at the left side here now, and the C is at the right side, and B is at the top side of the diagram. So we have seen it that what is just mentioned now is the ship is then 13.6 kilometer east of A. East of A. So we have seen that east of A is as distance to that 13.6 kilometer, and that is what we have indicated. Now, back to this slide. We needed to get some values and complete them here. Find the distance AB. That's the question we're asked to find. We're asked to find how far is from A to B. So the distance AB, that's what we want to find. And if you look at this diagram very carefully, it has turned to a triangle. But what type of triangle is this? Maybe we'll proceed, we'll get to know the type of triangle it's likely to be. It is not is not a right angled triangle. It's likely to be scalene triangle on equal sides and on equal angle. Let's proceed and see. And if you look carefully at those red ink, they are identifying the remaining angles. At 140 degree, the one written with black ink, what makes 90 extend to 140 is 50 degree, which is corresponding to angle at C, 50 degree as well. So we have that as 50 degree. Look carefully again. What will make 50 degree a 90 degree at point B? The extended part of that 140 degree is 40 degree, which we have written inside of that triangle. And also, if we look carefully at point A, we see 45 degree. What will make it complete 90 degree as well is also 45 degree. That one has been indicated as well. And this is corresponding to the angle at B. If we look straight up, is at 45 degree. So that 45 degree plus 40 degree, it will become 85 degree. And that is how we form the angle at that point B. and the angle at point C is 50 degree, the angle at point A is 45 degree. If we look at this carefully, we would see how those corresponding angles are measured to be equal to each other. Corresponding angles are equal. That one is established, and 50 degree is also 50 degree at point C. The later part of 50 degree, which is 40, that will make it 90 degree, is what is added to 45 that comes to be corresponding angle from point A, which is 85 degree. So at point B we have 85 degree, at point C we have 50 degree, at point A we have 45 degree. So all those values that are formed can easily make it convenient for us to find distance AB. And to do that, please let's look at this very carefully. We are going to adopt sine rule, meaning that we have studied sine rule earlier, and look at this side where it has 13.6 kilometer directly facing the angle that has 85 degree. So we can relate that together as sine B over AC, which is at the right hand side. Okay, and not that alone, what we actually wanted to find is length AB, and the angle facing that is 50 degree, as we have seen it at point C here. So meaning that sine 50 degree over AB is equal to sine 85 over 13.6. So this is what we have. Then we'll simplify this further, and what we'll first do to that is we'll cross multiply, and when we cross multiply, we're going to have AB times sine 85 then is equal to sine 13.6 sine 50. So we'll multiply them in that order, and we'll divide both sides by sine 85, which is AB is equal to 13.6 sine 50 over sine 85. And numerically, we can simplify that. What we have as 13.6 sine 50 is 10.42, and sine 85 is 0.996. And the length of AB is concluded to be 10.5 kilometers. So that is how we have the length of AB here. What we have adopted here is sine rule. At times it may appear to you and to use cosine rule. Just make sure you study that triangle very carefully and know the one that is directly facing the angle that is facing the side will take the same letter. The angle that is facing the side will take the same letter in that order. Okay, let us proceed. We're going to have, okay, this is another question we asked to, we are given a boat sails from point A on a bearing of 140 degree for 40 kilometer to another point now, to point B. Then sails on a bearing of 250 degree for 80 kilometer to another point now, to point C. So we have to take these three questions and do it. We first have a point A. This is point A, and that bearing of 140 degree will come in that direction for 40 kilometers. So 40 kilometers is that distance between A and B, and that angle that form from A to B is 140 degree, just as we have identified it. Then after that, from B, we said we were told that then the boat sails on a bearing of 250 degree. That is working again now. So we have 250 degree sails again, and for 80 kilometer to C, just like we have seen it. We started drawing from the north and we move clockwise more than 90, more than 180, but not up to 270. Then we have the line, and it extends by 80 kilometers. So that is actually the diagram. And what we're asked to do now is, to find the distance AC. Look at where we started from and where we are now. That is the distance we are asked to find. We want to find where that blue ink drawn across. Please, let's be very careful and look at this very well. The first thing we needed to look at here is that we want to know the remaining part of, or the angle at B. The angle at B. And to know the angle at B, we have already seen 250 degree. And also from point A, we have seen 140 degree, and what extends 90 degree is 50 degree. So that 50 degree is corresponding to the angle at point B, as we can see that red ink. So 50 degree to that is equal to 50 degree corresponding angle. All right, let's take note of that. And another one is that we are seeing it from here, that the little portion of this side, after we have drawn 250 degree at point B now, after we have drawn 250 degree, do not forget that when we extend 180 degree and it continues to form 250 degree, that will be 70 degree at that third quadrant now. So the later part of it that will make it another 90 degree in that place is 20 degree. Or we say that we started from north, coming straight to form 270, and the later part of it that will make it complete 270 is 20 degree. So that 20 degree is written, that 50 degree we just calculated is written as well, and the angle formed at point B is now 70 degree. Do not forget we have the side AB, which is 40 kilometers, and we have the side BC, which is 80 kilometers. So with that, we can couple it together and make use of cosine rule to find the distance AC, which we are going to do that now. Please take a careful look at this. We want to find AC, and this is the formula that we have adopted from sine rule, because AC, as it is now, is the side facing that angle 70 degree at B. So we have AC square is equal to AB square plus BC square minus 2AB times BC cos B. Cos B 70 degree facing the side AC, just as it has been mentioned earlier. So the unknown here is AC. AB is 40 kilometers, it is written. BC is 80 kilometers, it is written as well. So we can have AC square is equal to 40 square plus 80 square minus 2 times 40 times 80 cos 70. Then our 40 square is 1,600. 80 square is 6,400. Then 2 times 40 times 80. 2 times 40 is 80. 80 times 80 is 6,400 cos 70. Then we can proceed to add 1,600 plus 6,400 to give us 8,000 minus 6,400 cos 70 will give us 2,188.93. Then when we simplify that, meaning when we say 8,000 minus 2,188.93, it will give us 5,811.07, and we take the square root of both sides. When we do that, we're going to have the square root of 5,811.07 to be 76.23 kilometers. And that is the distance AC. That's the distance between point A and point C. Another thing we have to find here is the bearing of C from A. And with that, we can use cosine rule. When we use cosine rule to take care of that, we would see that the angle we are finding now is that angle that will come from, we needed to find the angle at A and we had it to 140 because the bearing of C from A is that we go to A. We now want to see where C is standing. That is what we mean by the angle of C from A. So we are at A. The north of A will move clockwise and will come straight down and will touch that blue ink. That will form the angle. But the angle inside this triangle is what we first find. The angle at A. That angle inside the triangle is what we first find. And when we do that, we're going to use sine rule. And to use sine rule for that, do not forget that the angle we are finding now is the one facing 80 kilometers. And we're going to make use of that angle at point A. So also, we're already given and we're already taking, we know what angle at point B is 70 degree. And it is directly facing what we just calculated now, which is 76.23. And after we have done that, please do not forget that that was what we've calculated not quite long, 76.23. So we proceed to have it this, we now write sine B over AC is equal to sine A over BC, which is sine 70 over 76.23, the one facing each other, is equal to sine A over 80, which is equally facing that. So what we're finding now is that sine A and precisely A angle. And to do that, we can cross multiply and make sine A the subject of formula to give us 80 sine 70 over 76.23. And when we simplify that, we're going to have 0.9861. And we take the inverse sine of both sides. Then the sine at the left hand side will be cancelled out. We're going to have A is equal to arc sine of 0.9861. And when we find what the arc sine of 0.9861 is, it's going to be 80.44. Do not forget that we are not concluded yet. We have to add 140. Sorry, that should be 140. So we have to add 140, the angle that is coming from the north that touches that direction from B, because that is what we are including to add together to make it complete, to meet the blue line, which will form the bearing of C from A. So we're going to add that 80.44 plus 140. And when we do that, we're going to have 220.44. That should be corrected. So 220.44 degree, and it can be expressed in minute as well. So that minute conversion, we'll get another slide and we're going to explain how we convert angles from radian to minutes and to degree in that order. So the answer here, it will be 80.44 plus 140, and that will be 220.44 degree. So that is number B. Let's proceed to look at number C now. We asked to find the bearing of A from C. So let the bearing of C from A be x, what we are asked to find now. And the angle at A, do not forget we have calculated that to be 80.44. Then, if we look at this very carefully, we would see that the angle at A is having 40 degree, the later part of that 50 at the southeast of A, which will make it 90 degree, is having 40. So that 40 will be what will make that 50 equals 90. So we are adding it to the very little part that is showing that blue ink to complete that particular angle. And we have it to be x plus 40 is equal to 80.44. We have already calculated that angle 80.44. So with this now, please let me take this again. We have already taken that 40, and that 40 is valued from what we have the later part of 50 that will make it 90 at southeast of A. If you look at that carefully, and the very little part that will make it complete is what we have represented as x, which is corresponding to what we want to find, the bearing of A from C, because we are at C now. We now want to find that little portion of angle from C, the angle that we will draw from the north of C clockwise to come and touch that blue line. That is the angle we are finding, and it is corresponding to x. So we have x plus 40 is equal to 80.44. And with that, already our 80.44 is found to be angle at A, which we have just calculated now in the previous slide. So we can now simplify that. We'll take 40 away from both sides, and x will be 40.44. So, and that's the concluding part of this question. So the bearing of C now from A is 40.44. Thank you so much for listening. Please, I want to click subscribe button if you have not done so, and you can equally hit that bell. It will always give you the notification of new videos as it will be uploaded. Thank you so much for listening. Do have a nice day.